Welcome back. Today we're going to be talking about rational number operations, day number 1. Our content objective is students will be able to find the sum or difference of rational numbers. Our language objective is students will be able to discuss whether your estimates make sense. Why am I learning this? Well, it's important for many real-world problems like finding the rational distance between two objects. So let's first go over some vocabulary. Please remember that a rational number is basically any number that you can write as a fraction. So this is a fraction because we can write it as 6/10. This is a fraction just by simply putting it over 1. 2/3 already is a fraction, so we know that's rational. 75% could be expressed as 75 over 100. But just FYI, the official definition is stated as a rational number is any number that can be written in the form of A over B, hence a fraction. But very specifically, where B cannot equal 0. So let's take a look at this problem here. It says, in Numberline School, there is one straight hallway. The numbers on the classroom indicate the distance from the main office, which is 0. Mark the location of the following classrooms on the map of Numberline School below. So here we have Mr. Bowen at -3 1/4. So here we're going to the left, -1, 2, 3 1/4, probably right here. Miss Abe is at 3 1/2 from the office, so that's going to be 1, 2, 3 1/2, which is right here. And then we have Miss England at -6 1/4, so we're going to the left, 1, 2, 3, 4, 5, 6. 6 1/4 is probably around here. Miss Chichester is at 5 2/500, so it's 5 2/500, which is approximately right here. We have Mr. Franks, which is -8 1/3, so here's 6, 7, 8 1/3, probably around here. And then Mr. David, which is -5 2/10, which is approximately around here. So now we've basically listed all the different teachers on our number line from Numberline School. Now we have a few questions. The first question is, whose classroom is further from the main office? Is it Miss Abe or Mr. Chichester? Estimate and then find the actual distance. So here, who's further from the office? Is it Miss Abe or Miss Chichester? Hopefully you can see visually on the number line that you see Miss Chichester is further. Okay, so I'm going to say Miss Chichester. Then it asks me to find the actual distance. Specifically, how far is it from Miss Abe's and Miss Chichester? So here I would say it's 1 7/500. How did I get that? Well, I was finding the distance of 2 points on a number line. If you recall, we did have a formula, which is the absolute value of P and Q. Okay, so here I'm going to call this P, I call this Q. I'm going to find the difference between these 2 points, and I'm taking the absolute value of it. If I subtract these 2 points, I would get a -1 7/500, but taking the absolute value of that would give me 1 7/500. Now, I could have also interpreted this question to say, how far is the actual distance from the office to Miss Chichester? In that case, I would say 5 2/500. Next question, it says Joe has Mr. Brown's class first hour and Miss England's class second hour. How far must he walk to get Mr. Bowen's class to Miss England's class? So starting here, he's going to end up going to Miss England's class, which is here. So what would I do to figure out how far he must walk? It's just like the previous example. What we're asked to do is to figure out the distance. And remember, there is a formula that we've learned from a previous lesson. If we're trying to figure out how far apart these numbers are, most of you automatically know logically, I'm going to subtract it. We do have the formula. We're taking the absolute value of P minus Q. So any of them you can consider P or Q. So what's going to happen is you're going to take the absolute value of them. And here we have -6 1/4 minus 3 1/4. Here, if you add the opposite, it's basically -3. So here, if you add the opposite, you find that the fractions cancel each other out, and you're basically left with -6 plus 3. And the absolute value of -3 would just be 3. So Joe must walk 3 units. Next question, what is the distance between Miss Chidester's class and Mr. David's class? So here we're trying to look at Mr. David's class and Miss Chidester's class. So once again, we're going to find the distance between the two by simply finding the difference of the absolute value of the two numbers. Let me rephrase that. We're going to take the absolute value of the difference of the two numbers. So does it really matter which order you write them? No. So here I'm going to go ahead and set it up as the absolute value of negative 5 2/10 minus 5 2500. So once you do this here, we're going to add the opposite. We can see here there are more negatives, obviously, than positives because they're both negatives. So since they're both negatives, we combine them, leaving us with negative 10 and 4500ths. And then from there, what we're going to do is take the absolute value, which would give us 10 and 4500. So what is the distance? I would say the distance is 10 and 4500 units. Okay, next question. What is the distance between Mr. Frank's class and Miss England's class? So same idea. So at this point, I'd like you to go ahead and pause the video and try this one by yourself. Okay, so let's see how we did. So first, we're finding the distance between Mr. Frank's class and Miss England's class, which is right here. So we're going to find the absolute value of the difference between these 2 points. So, which should have given you 2 and 1/12. Okay, and here let me show you what we did. We took the absolute value of negative 8 and 1/3 minus 6 and 1/4. Here, since it's subtraction, we can add the opposite. We see there's more negatives. How many more negatives are there? There's 2 and 1/12 more negatives. So taking the absolute value of that would give me 2 and 1/12. Would we be able to plot a location of negative 18 and 7500ths on the line? What about 21 and 7/8? The answer is yes, you can. On our number lines, first of all, number lines go on forever, so we may not see it on our particular number line, but if we know that these lines extend on forever, so would we be able to? Yes, because number lines go infinitely in both directions, so as long as it's any real number, we would be able to plot it on our line. Okay, so in order to add or subtract, you must have the same units. Okay, so for example, 3 apples plus 4 apples is 7 apples. Okay, 24 plus 7 is 31. 3.2 plus 4.01 is 7.21. 1/2 plus 1/3, you need common denominators, and then you would get 5/6. If they're not the same units, I can't add them. I can't add apples and bananas. Okay, and here, why is this wrong? Okay, this 2 is in the tens place. This 4 is in the ones place. This 7 is in the ones place. So it's in the incorrect spot. So therefore, they wouldn't be the same unit. So the 7 should be shifted here, aligned with the ones place. Same idea here. This is a very common mistake a lot of students do with adding decimals. They like to push all the numbers to the right, and then they add things, and it's incorrect. So for example, this is the whole number. Notice it's not being added to this whole number here. This is the tens place, and it's not being added to the tens place here. So it's extremely important that you keep in mind to make sure the units are the same. The ones are aligned with the ones, the whole numbers are aligned with the whole numbers, the tens are aligned with the tens place, etc. And here, a very common mistake some people would do is simply add the numerator, add the denominator, and that is incorrect because in order for us to add fractions, they need to be the same denominator. They have to be all in sixths, all in halves, all in thirds, etc. So from 5th grade, we did practice modeling, modeling what 1/2 is, 1/3. So this is a great example to prove to you can't simply just add the numerators, add the denominator. They're not the same. Okay, we need the same unit. So here, if you split these in thirds and you split these in halves, you'd be able to see that you can compare them more. You'd be able to actually compare them because they're in the same units. So together, there are 5/6. Now on a number line, okay, you would think of it as 1/2 plus a third would be 5/6. Same idea. We need to make sure we have the same units. In this case, the same denominator. All the pieces are cut the same number of pieces. So it says here, estimate and then find the sum or difference of each of the following. The reason why estimate is part of the instructions is because some students tend to forget to line up the decimals, and they're not combining the correct units. For example, they're not correctly adding all the ones place, the tens place, the tenths place, etc. So estimating kind of allows us to look at our answer and assess whether or not it makes sense or not. Because sometimes our answers don't make sense, but we kind of go with it anyway. So we have to be very careful. So here, if you have -12 and 7/10 plus -17 and 7/10, what would I expect my answer to be? Well, I see they're both negative, so I definitely expect there to be more negatives, around maybe, let's see, 29 to 30. So if my answer is not close to that, I know I did something wrong. So here, what I'm going to do is decide right now there are more negatives, so I'm going to go ahead and write the negative sign. The reason why I do that is because sometimes I get caught up in side work and working out the numbers that I completely forget to write the sign. So that's something that I do first. So let's see, how many negatives are there? Well, they're both negatives, so let me just combine them real quick to see how many I have all together. I see here that I have 30 and 4/100 negatives, and that was about approximately what I expected to have. So I have 30 and 4/10 negatives. I have absolutely no positives. So how many more negatives are there than positives? I would say 30 and 4/10. So that would be my answer. Okay, so let me just try one more with you, and then you can try one by yourself. Okay, so here we have 15 and 7/10 plus -9 and 22/100. So first of all, my answer should definitely be positives, and I would expect there to be approximately maybe around 6. Okay, so I want my answers to be somewhere around there. If I get like, I don't know, 24 or something like that, I know something's wrong. So here I do see there's more positives, so I'm going to go ahead and say there's 15 and 7/10 positives. And so I know my answer right away is positive. Just remember, we typically don't write this sign, but this kind of tells me I did take care of the sign before I went off and did some side work. Here we have 9 and 22/100 negatives. So let me just move this over right here so it's not in the way. So these are positive, these are negative. So how many more positives are there than negatives? Well, let's find out. I'm going to have to borrow, so this becomes 10. This will become a 6. 10 minus 2 is 8. 6 minus 2 is 4. Here, we can't do 5 minus 9, so you can see it's just 15. So 15 minus 9 is 6. So we have positive 6 and 48/100 as our final answer, and it is positive. So no, you don't have to write the positive sign. It's just there as a marker for me to know I did assess if there was more negatives or if there were more positives. Now, could we use a number line to estimate? Absolutely. Okay. So now at this point, what I'd like you to do is go ahead and pause the video and try number 3 by yourself. Okay, so hopefully after doing number 3, you should have gotten that there are more negatives. This one's close, but notice this one's 3 and 3/10, and this one's 3 and 5/10. So there are more negatives. Specifically, there are 211 10,000ths more negatives. So our answer was negative 211 10,000ths. Okay, so now, same instructions, except now we have subtraction. So hopefully you remember for subtraction, we need to make sure we add the opposite. So here, since it's subtraction, I'm going to add. The opposite of 14 and 6/10 is negative 14 and 6/10. So here, I'm going to assess if there's more negatives or more positives. I'm definitely going to say there's more negatives, so I'm going to write my sign before I move on. So I see there are 14 and 6/10 hundred. Sorry, 14 and 6/10 negatives, and 4 and 9/10 positives. So I need to compare how many more negatives are there than positives. Well, let's find out. We're going to borrow. 16 minus 9 is going to give me 7. I can't do 3 minus 4, so it's going to be 13 minus 4, which is going to give me 9. So my answer is going to be negative 9 and 7/10. Okay, so the only difference between number 4 and the previous examples was the fact that I had to remember, oh look, it's subtraction, so I need to make sure I add the opposite. So with that said, I'd like you to pause the video and try the next 3 on your own. Okay, so I'm going to go ahead and quickly go over the answers. What I'm going to do is remind you, since it's subtraction, to add the opposite. And that's going to give me 14 and 79/100. For number 6, once again, we see subtraction right here. So we're going to add the opposite. So here we're going to see where there's more positives, specifically 21 and 62/100 more positives. And hopefully you're estimating along the way and making sure, does my answer make sense or does it seem off? So number 17 here, if you add the opposite, since it is subtraction, I really want you to estimate, because this is one that a lot of students tend to get incorrectly. If we have negative 18 and negative 16 and 8/10, obviously there are more negatives, and we expect there to be around 34. Okay, since they're both negatives, we combine them. The main reason why a lot of students get this one wrong is because they forget where the decimal belongs. One way I like to teach it is I like to remind you that the decimal belongs at the end of the number, very similar to how a period belongs at the end of a sentence. So here, it should have been negative 18 with the decimal at the end, and then your negative 16 and 8/10, since they're both negatives, you simply combine them to see how many you're left with, which should have been negative 34 and 8/10. Okay, so now it says find the sum or difference of each of the following. So here for number 8, we have 1/8 minus 5/6. Please refrain from just subtracting straight across. We always need to make sure whenever we're adding or subtracting that they're in the same units. So hence, we need to make sure they have the same denominator. So here, what I like to do first is decide, okay, which one's larger, 8 or 6? 8 is obviously larger, so I'm going to go by multiples of 8. Can 6 be made into 8? No. Can 6 be made into 16? No. Next multiple is 24. Can 6 be made into 24? Yes. So I'm going to go ahead and make 24 my lowest common multiple. So here 8 is going to have to be multiplied by a 3, but whatever I do to the denominator, I must do to the numerator. So essentially I'm multiplying by 3 over 3. I'm allowed to do this. This is called the identity property of multiplication. So here 3 times 1 is 3. 3 times 8 is what's going to give me this 24. So one more time, the reason why I'm allowed to do this is because 3 over 3 is 1. Multiplying any number by 1 doesn't change its value. It simply makes it look different. So in this case, it's nice because we want our denominators to be 24. I'm going to bring down the subtraction here. 6 is not yet a 24, but I could make it by simply multiplying by 4. So if I multiply 6 by 4, I'm going to multiply 5 by 4 as well, which is going to give me 5 times 4, which is 20. Let's check. 6 times 4 is 24. That's exactly what I needed. Now here, I do want you to rewrite this. Our denominator is a 24, but I want to rewrite the numerator as 3 minus 20. Now this is nice because then you can easily change this to, hey, I see subtraction. I'm going to add the opposite. Then I can see there's more negatives. There are 20 negatives and 3 positives. So how many more negatives are there than positives? I would say 17. So I'm going to always check to see if my fraction is reduced or if it needs to turn into a mixed number. And at this point, I would say it is reduced. So my final answer is, I know that the difference between 1/8 and 5/6 is negative 17/24. Okay, so let me show you one more. Here for number 9, now the only difference is I have to make sure I'm going to turn all my mixed numbers into improper fractions. So here we're going to do, ignoring the negative sign for a second, 8 times 1 is 8, plus 7 is going to be 15. So we have negative 15 eighths plus 3/4. So just like in the previous example, I like to identify which one's the greater denominator at this point, which is 8. I go by multiples of 8. Can 4 be made into 8? The answer is yes. So that's going to be my lowest common multiple. Now at this point, I'm going to ask, is an 8 an 8? I'm going to say yes, so I don't really have to change it. But if you're curious why it doesn't change, you can think of it as, hey, I'm multiplying by 1. Oh, look, see, 8 times 1 is 8. Negative 15 times 1 is still negative 15. Now, is it necessary for you to show me that you're multiplying by 1? Absolutely not. But I just wanted to show you why that works. So here we're going to go ahead and add. Is a 4 an 8? The answer is no, but we could transform it to make it an 8 simply by multiplying by 2. So here, 3 times 2 is 6. Let's double check this. 4 times 2 equals 8. Perfect. So at this point, we're going to go ahead and rewrite this. Our denominator is an 8. I'm going to rewrite this as negative 15 plus 6. It's already addition, so I'm not going to have to add the opposite. That only works. I only use that when it's subtraction. So here I see there are definitely more negatives. How many more negatives than positives? Well, there's 15 negatives, 6 positives. So there are 9 more negatives than there are positives. Now this is improper, so I am going to want to turn that into a mixed number. Before I actually do the side work, I want to remember that it is negative. And again, I do this because I often forget when I do some side work, I kind of forget about the sign and I'm going to get it wrong simply by negative, which I don't want to do. So here we're going to do 9 divided by 8, which goes in once. It's going to leave me with the remainder of 1, so it's going to be 1 and 1/8. So notice here I already marked that it's going to be negative, so it's going to be negative 1 and 1/8. So I would say I know that the sum, this time it's addition, is negative 1 and 1/8. Okay, so the identity property basically is when you are doing something to it that doesn't change it at all. So for example, multiplying a number by 1 doesn't change it, or adding the number 0 doesn't change the value. Okay, so the word identity has to do with sameness. We use this word whenever we recognize the sameness about things. For example, you might say that a Halloween costume cannot really hide a person's true identity. So here, like I said, multiplying a number by 1 doesn't change it. A 2/3 still remains a 2/3. Here, multiplying 2/3 by 5/5, which by the way is 1, becomes 10/15. You may think it looks different, but if I were to reduce this, guess what? It gets back to 2/3. So is it truly different? No, it's not covering its true identity. So there's an addition property. There's identity property of addition. That's when you add 0, because adding 0 doesn't affect the identity. Okay, 0 is called the additive identity for that purpose because it doesn't change a value of a number. And then we have the identity property of multiplication. And guess what the multiplicative identity is? Hopefully you guessed that it's 1, because multiplying a number by 1 doesn't change the identity of a number. Okay. So sorry, this is in the way, but just know 1 is called the multiplicative identity. So this property is used when writing equivalent fractions, and we always need equivalent fractions when we are trying to add or subtract them, because again, we need them to be in the same units. They all need to have the same denominator. So here, go ahead and pause the video and try number 10. Okay, so for number 10, what we're going to do first is we see that it's subtraction. So I'm going to have to add the opposite. So here I'm going to add the opposite, which is going to now, I'm going to turn this into an improper fraction. This is 24 plus 1, so it's 25/4, plus here, 5 times 1 is 5, plus 3 is 8, so we have 8/5. So at this stage, what we're going to do once again is identify which one's larger, 4 or 5. 5 is obviously larger. So I'm going to go by multiples of 5. Can 4 be multiplied to give me 5? No, Next multiple is 10. Can 4 be multiplied to give me 10? No. Next multiple is 15. Can 4 be multiplied to give me 15? No. Next multiple is 20. Can 4 be multiplied to give me 20? Yes. So that's going to be my lowest common multiple. Is the 4 of 20? The answer is no. So we're going to have to multiply this by 5 to make it 20. So multiply by 5, multiply by 5. 25 times 5 is 125. Let's check, does 4 times 5 give me 20? Yes. So now I'm going to go ahead and change that to addition. 5 times what will be a 20? We're going to have to multiply by 4. So 8 is going to have to be multiplied by 4 as well. 8 times 4 is 32. Let's double check. Does 5 times 4 give me 20? Yes. So once again, at this stage, we're going to go ahead and rewrite it. Our denominator is going to remain a 20. I'm going to go ahead and add these numerators, 125 plus 32. I can definitely see there's more positives. That's all there is. So we're going to combine those, and that's going to give us, let's see, 157 over 20. This is definitely improper. So I'm going to go ahead and divide this and turn it into a mixed number. It's positive, so it's going to remain positive. So here, doing some side work, 157 divided by 20. 20 cannot go into 1 or 15. It can go into 157, let's see, about 7 times, which is 140, which is going to leave us with a remainder of 17. So it's going to be 7 and 17/20 as our final answer. Okay, so now once again, I'd like you to pause the video and try number 11 by yourself. See how well we did. Here, it's already addition, so I'm not going to have to add the opposite. I'm going to first check the largest denominator is a 4. Okay, can 3 be made into 4? Nope. Next multiple is 8. Can 3 be made into 8? Nope. Next multiple is 12. Can 3 be made into 12? Yes. So 12 is going to be our lowest common multiple. Okay, is a 4 or 12? The answer is no. But we could make it if we multiplied 4 by a 3. So 4 times 3. So 3 times 3. So be careful. This is a negative 3 times 3, which is negative 9. Okay, we want to be very mindful of the sign to make sure we write it here. We're going to bring down this plus here. Is a 3 a 12? The answer is no, but we could transform it into a 12 by multiplying it by 4. So here, I'm going to have to multiply by 4 as well. So notice this is a negative 2. This is a negative fraction, so we want to keep this negative. Negative 2 times 4, which is a negative 8. Let's double check. 3 times 4 is 12. That's good. So we're going to rewrite this 12 as our denominator. We're going to go ahead and write negative 8 plus, negative 9 plus negative 8. There are definitely more negatives. There's 9 negatives and 8 negatives. So altogether there are 17 negatives and 0 positives. So there are 17 more negatives than positives. And 12 is going to remain our denominator. We do have a improper fraction, so we're going to have to divide to turn it into a mixed number. I'm going to put the negative sign so I don't forget. Now off to the side, let's go ahead and divide. 12 goes into 17 once with a remainder of 5. So it's going to become 1 and 5/12 as our final answer. So I'm going to say I know the sum is negative 1 and 5/12. So at this point, I'd like you to go ahead and try numbers 12 and 13 by yourself. Okay, so let's see how well we did. For number 12, first you hopefully turn it into improper fractions. Okay, now from here we need a common denominator, which would have been 15. So you'd have to multiply and give us a new fraction of negative 40 over 15. And here we would get negative 48 over 15. 15 is our lowest common denominator. We're going to combine numerators together, giving us negative 88/15. We can't leave it improper. We're going to change it into a mixed number by dividing, giving us negative 5 and 13/15. Number 13, you're going to first turn it into an improper fraction. We need a common denominator. And then from there, we're going to rewrite it as 49 minus 60 over 28, which gives us negative 11 over 28, which is already a reduced fraction, so that would be our answer. So hopefully you got those right. If not, feel free to rewind back to the previous two examples and try that on your own again. Well, guess what? That concludes our lesson for today. Thank you so much for tuning in. And as always, until next time, bye.